In this video, we are going to talk about absolute value functions, what is an absolute value function, and how to transform an absolute value function. So what is an absolute value function? What is it at its basic definition? It is a function. It is a function that has a variable inside of absolute value bars. So an example would be like y equals 2 times x plus 1. X plus 1 minus 3. There's an x inside of absolute value bars. So it's an absolute value function. Now, let's talk about what the parent function. So in the last video, we spoke about what a parent function is. It is the most basic of that type of function. So it is simply y equals the absolute value of x. That is the most basic absolute value function that there is. Just x inside of absolute value bars. So we are going to graph this. We're going to take a look at what it looks like. So let's do that. Let's make a table. Right here, we're going to make a table. I'm going to go from -2 to 2. So -2, if I take again, this is the absolute value of x. The absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0, 1 is 1, and 2 is 2. Right? Remember, absolute value always becomes positive. So this looks very similar to parabolas in the sense that it is symmetrical over one point. So let's look at what that looks like on a graph. So I have 0, let's zoom out a little bit so we can see the points. So we have 0, 0. Well, let's go -2, 2. -1, 1. 0, 0, 1, 1, 2, 2. Now, what's the difference between a parabola, right, which it was 2, 4. This is what a parabola looked like, right? It curved up, it went like that, versus this absolute value function is a little bit more rigid, where it looks like a V. That is consistent. An absolute value function will always look like a V, the same way a parabola will always look like a U, okay? It will always look like a V, whether it's an upside down V or a right side up V. So it might look like this. It might look like this. It might look like that, but it will always be a V, and it will always also, like a parabola, have a vertex. Now, this is a piecewise function by nature, okay? What is the function? Well, I have f of x equals, it is 2 lines. If you look at this, the absolute value function is a piecewise function. This first one is, the equation is -x, right? The -1, a slope of -1, a y-intercept of 0, when x is less than or equal to 0. And this other portion here is x, when x is greater than or equal to 0. Now, it doesn't actually matter that it satisfies both of these. It's okay because at the end of the day, they meet. So at 0, 0 is the point. This is the piecewise function. Now you can write it as greater than if you want, but one of them has to be equal to, at minimum, one or both. So this is the actual absolute value parent function. So f of x right here, let me rewrite this. F of x equals the absolute value of x, which is equal to this. It is a piecewise function by nature. It is the positive x and the negative x, but because this becomes positive, it's only the positive portion of it. What is the domain of this function? Well, we know that we can input any number, right? The domain is all real numbers. The domain is all real numbers, or from negative infinity to infinity. But the range is what? Well, what will never be an output of this function? A negative number. So my range is x is greater than or equal to, not x, y is greater than or equal to 0. That is the only outputs you will ever get from that parent function. These are not the domain and ranges of every absolute value function. It is the domain. The domain will always be all real numbers, but the range will not necessarily always be all real numbers. Okay, so let's talk about transformations. Same concept as, parabolas. Exact same thing. So here I have my absolute value graph. Let me move me. Here's my absolute value graph, right? This is what we just graphed on the other application. So what happens when I add a number to the end outside of the absolute value? It goes up or down. If it's positive, it goes up. If it's negative, it goes down. Same thing as a parabola. Okay, what happens if I put a number inside of the absolute value? Inside of the absolute value. Well, I'm gonna make this a plus h. So we see that when you have plus 1, where does it go? It goes to the left. It does the opposite of what you think it's gonna do. Same as a parabola, exact same thing. Look, it is directly affecting the x. Remember what I said in the first video. Think about if you have an x. A lot of times if it ends on bad terms, right? Your x does the opposite of what you want them to do. So think it's directly affecting the x, so it's gonna do the opposite of what I want it to do. So if it's plus 7, x plus 7, it's going to the left 7. If it's x minus 4.9, it's going to the right 4.9. That's why the original function is x minus h, because then it says, okay, well, if it's minus, then I know plus 1, positive 1, is going to go to the right. That's why the minus is there, is to communicate that it is the opposite. Okay, next, we have that coefficient on the outside. That coefficient is a 1 if it's not there, right? This is technically the same thing as saying 1 absolute value times the absolute value of x. Same concept as quadratics. If it goes up, it's a vertical stretch, which means it gets skinnier. Again, it stretches out. Okay, it's like if you think about a little kid, like a little kid is a little bit chubby. If they grow and don't gain weight, they get skinnier. If they get taller but don't gain any weight, they get skinnier naturally just because they grew. So think about it like that. This is my little cousin or me. Actually, this is literally me. And then I grew up. Actually, I gained weight as I grew up. So I got taller and wider at the same time, but we're not going to talk about that. So that is a vertical stretch if a is greater than 1. If a is between 0 and 1, again, same concept, it gets wider. So if I just play this, look at how it just plays. It gets skinnier and then it gets wider. It's like doing jumping jacks. Okay, so it's really important that you know that if it's between 0 and 1, it's gonna get wider. It is a vertical shrink. It's like squashing something. All right, and then lastly, if we have a negative in front of that, if A is negative, then it flips upside down. Same thing as when we had parabolas. So if I have y equals -3, let's turn this off. -3 absolute value. This is Desmos. Desmos is great. Absolute value of x minus 4. Actually, plus 4. Plus 6. Let's do that. So we know it's going to go up 6, right? Up 6. It's not going right or left, so it's staying on the y-axis. So it's going up 6. It is going to become skinnier from that, right? It's going to be a vertical stretch. It's going to get skinnier. And then it's going to be upside down. So let's look at it. So it should be up here at 6, skinnier and upside down. Boom. There it is. Okay, so let's go back and define them. Let's do a little summary. So we have same thing as, let me do some erasing here. We have the same exact things as last time. So this H is a vertical shift. Oh, you can't see what I'm doing. There it is. It is a vertical shift from X, right? So not vertical. I'm so sorry. It is a horizontal shift. It is a horizontal shift, meaning it goes right and left. And again, it does the opposite of what you think it's going to do. It's going to go, if it's plus, it's going to go left. If it's minus, it's going to go right. This K is a vertical shift, meaning it's going to go up or down. This is going to do the thing that you think it's going to do. Plus 3 is up 3. -2 is down 2. This right here, again, we're not going to deal with this right now. We're going to address that at a later time. It's there, you can write it down, but we're not going to discuss it in this video. So this is a vertical reflection, meaning it is reflecting down, meaning it's reflecting over the x-axis. So reflect over the x-axis. And then this is a dilation, right? But it is a vertical stretch if A is greater than 1, and a vertical shrink if it's between 0 and 1. So that's your little summary. So let's go and do a few examples, and then we're good. So again, we remember from our parent function that it goes up by a factor of 1, okay? If we have a 2 here, it goes up by a factor of 2. It has a slope of 2 essentially, right? This is our new slope. Instead of it being -x and x, it's going to be -2x and 2x. Over here, this piecewise function becomes -2x and 2x. So, but it's going to go down 3. So we have a vertical stretch times 2, and we have down 3. Two things are happening to this. So I'm going to go down 3. It was over here. Our parent function looks like this. This is our parent. We always draw the parent because we want to compare it. And then we have, it goes down 3. And then instead of it going to with the slope of 1, it's going to have a slope of 2. So up 2 over 1. Up 2 over 1. Again, an absolute value function is just 2 lines together. And then there's our function. That's 1. Then we reflect it. There you go. Let's do the next one. So for the next one, why is it not doing anything? Oh, okay. So for this one, we have negative x plus 3. There are 2 things happening here. One, it is reflecting over x axis, a vertical reflection. And then this is going to the right or to the left? To the left. It's doing the opposite of what you think it's going to do. So real quick, I'm going to draw my parent. So it's going to the left 3, 1, 2, 3. And then it's going to flip upside down. So instead of going up 1, right 1, I'm going to go down 1, right 1. It hasn't gotten any skinnier or anything, any skinnier or wider, because it hasn't, there's no number, right? There's not like 2 here or 1/2. It's the same thing, but it's just flipped upside down. And there's your function. It looks weird. It looks like a check mark upside down because it's not full V because we moved it, but that's it.